All right, so today we're going to talk about my adventures and vessel hacking in general, mostly focused on the NEMA 2000 bus. But really, I was fairly new to vessel hacking until recently. I just had some other things that I did that made it pretty easy once I realized what I was up against. And that's what this talk is about. It's really my goals here are to get you introduced to the concepts of the NEMA 2000 bus, the ways that you can attack it that you might not be aware of. And if you don't have stuff already in your toolkit that you can attack it with, kind of, what you could purchase or build to do that. So disclaimer, please don't go on a cruise ship, hack the fuck out of that cruise ship, and then blame me. Thank you. You can do it. Just I was not involved. Um, all right, so today we're going to talk about, so it's just my intro and adventure. So this is really my weird rabbit hole where I ended up doing some boat stuff, and I will continue to do boat stuff because it's fun and easy. And hopefully you guys, after this talk, get interested too and want to do some boat stuff as well. I'll go over the vessel networks as a whole. So that's all the networks on a vessel. Not just the NEMA bus that we're going to be talking about in more detail, but also other shipboard networks. So also going to introduce some tools, some concepts, kind of give you guys a place to get started, a path forward if you want to continue vessel hacking after this talk. And then we should have some time for questions as well. So to start, who am I? I'm a dog dad, first off. So I have an amazing pit plot mix and we go on walks like every day. If you don't have a pet and struggle with just getting out of the house or mental health, like highly recommend it. I love biking, boating. I'm basically, since I do stuff in front of my screen professionally, I'm always trying to get outside if I have time off, but even hacking, it's not really work to me. It's fun. So just bouncing back and forth between getting away from the PC. A lot of times I'll have my biggest breaks when I'm on my bike or out on my boat or fishing. So, don't forget to step away, especially if you're stuck. When you can't touch the keyboard and you're like, well, what would I do if I was there? That's when you make progress. So yeah. I'm also into phones, radio frequency stuff. I do a lot of Meshtastic stuff. I have Comms for All is my company. I'm doing a challenge here today and tomorrow for Meshtastic. It starts at noon. So if you guys are curious about that, I'll have more details back in the conference building. And let's see, yeah, satellites and electronics. So I made badges. So I have a badge display out over there as well. Please ask me questions about badges. Really anything you're curious about, I'm approachable. Ask me questions. The worst I can say is I'm busy, so it doesn't hurt. I am a furry, and at DEF CON, a lot of times you'll see me running around as a panda. So this phone works, by the way. So like right now it's down at the conference center. It's not functional, but if you see me walking around with it, it probably is functional. So if you want to make a call, that's fine. Just don't call 911. I've had to tell the Las Vegas fire police department a couple times that they didn't mean to dial 911. They didn't think it was actually going to work. So my certs. Oh, and I was one of the founders of DEF CON Furs. So, if you are a furry or furry adjacent or just want to hang out with furries, honestly, there's a lot of people that up until a couple of years ago just weren't openly furry at DEF CON. They were doing cool stuff in the villages, main stage, etc. It's a really cool group. Come check us out. We have cool badges. We have generally a suite and, a lot of great parties and stuff. So, yeah, it's a good group. But anyway, so certs, I have kind of the standard stuff. I have a mix of blue team and red team. I came from the blue team world. I'll talk about my progression a little bit. So as a kid, I was really into video games. I became a video game hacker. From there, I held LAN parties and stuff because I was really into video games. So like holding LAN parties made me good at networking. And then I scared myself when I was hacking things. And there wasn't back then, there wasn't really the idea of oh, I can get a job in cybersecurity. It was, oh, I'm going to go to prison, so that was a little bit different. And so I scared myself. I kind of got out of hacking for a while and got into a career of network engineering because I already knew it from building those large networks for LAN parties. It's like, what can I make money off of, and do the thing. And then I fell back into security after I did some re-architecture of networks at my last company. I took over, there was no security program at the time, really. It was just built into IT. So I built out a security program and built out all the executive leadership, committees to support that. And if you have questions about blue team or red team, I do both. So, and then nowadays, I'm no longer with that company. That was actually right after last HackSpaceCon. But nowadays, I'm working with Red Seer, so they hold these conferences, and it's been honestly an incredible experience. I'm trying to help them build out the blue team services at their company, but I also get to help, educate and share with the community. Like my previous role, I was essentially a CISO, so I couldn't talk about stuff. It's a whole different ball game because like OPSEC, you can't go, oh, I made this cool thing for CrowdStrike, RTR, then oh, everyone knows your company is using that tool, uh, so I have a video. So, like, I don't want to make you guys feel old, but I'm about to. This was 30 years ago. We were worried about the same shit. Autonomous vehicles didn't go away. And, it's one of those things where a large vessel, like a cruise ship or an oil tanker or something, a lot of the technology that's on that boat probably is still 30 years old at this point. But what they're doing is on these networks, they're implementing one system at a time. More advanced autonomous systems. So yeah, just realize that, as boats get more complex, the ability to hack them becomes easier and easier. More systems, more attack surface. So it's, I guess a blessing on the red team side or a curse on the blue team side if you're trying to defend. So this is kind of the start of my adventure, my weird rabbit hole. Basically, I needed to test an autonomous vessel. We were doing wireless testing as well as some GPS testing for GPS spoofing for drift. We wanted to see if we could drift the boat and or teleport the boat to somewhere else. I was unable to use GPS SDR sim with my Blade RF because we couldn't isolate the RF of that, what I was going to transmit from just open air. And because of that, we took a little bit of a different approach. I thought like instead of spoofing GPS to the GPS receiver that's on the NMEA bus on the boat, why not just be the GPS receiver on the NMEA bus and emulate that? Because depending on their controls, I might be able to prove something out that helps them regardless, even if I can't spoof GPS over the air. So that's essentially what I did. And what this talk will go into a little bit, but it's more of a general NMEA talk. This is just like my journey, the reason I rabbit holed. I started, yeah, go ahead. So I'll go over that in a couple slides. Yeah. Sorry. Um, so basically, my first thought with this, I had to hack this boat. I'm like, the NMEA 2000 bus can't be that complex. I started looking into it, and I'm like, I know this. It's just a CAN bus, So I'm like, like I have a vehicle that's been driving itself since 2020. I run George Hotz's Open Pilot, and so I'm familiar with automotive and just CAN bus interfaces. Is like, can I use something there? Maybe I have something in my tool set already that I can use to make some progress here. So that was my rabbit hole, and I will tell you what I learned. So this is the overall kind of network diagram on a vessel. Understand that this is like a very limited one. Depending on the size of the vessel, this could be accurate. It could be, there might be stuff that's missing from this, but there also might be multiples of each type of network on a larger vessel. So, there might be many buses, there might be many IP networks. It really just depends on the scale of the vessel, what use cases they're trying to support. So there's the wireless, so think like, Wi-Fi on a ship, but also you'll have cellular and satellite, links back, for internet, as well as control channels, especially if it's an autonomous vessel. There's going to be some way to talk back. And then there's going to be shipboard networks, like supporting endpoints. Just think like your normal kind of IT stuff. Normal endpoints, could be Windows, Linux, whatever. They're supporting people on the boat doing their jobs. They could be passengers or they could be, crew, doing very important jobs. So that's a lead into something. There's on these networks, so you'll see they're kind of separated here. This is like the wireless is represented here with Wi-Fi kind of over there, but then you have your shipboard network. This is Ethernet. The blue is Ethernet. So imagine standard network, connected out to the internet. There, might be controls in place, obviously, between these networks, but a lot of times they are connected. And then you connect the lower level instrument networks via a gateway. So this is a NMEA or NMEA 2000 gateway. A lot of times these are IP, and they sit on the network, and stuff on that, anything on that network could communicate with that resource. It could also be an endpoint that's running gateway software that helps it communicate down to that bus. And in some of the more secure cases, they might have a gateway that's just like a USB gateway, hanging off there, so it's not exposed to the whole network. The instrument network, think about it tying together stuff like your engine, GPS receivers. AIS is like ADS-B for boats, essentially. It tells you the port that the boat's going to, speed, depth, draft, all that kind of stuff. Radar, we all kind of know what that does. Sonar, think depth, so the depth under your vessel. That can be a huge deal if there's bad data and your vehicle drafts 16 feet or vessel drafts 16 feet. And all of a sudden, that data is messed with. You might think that, you're good and you run aground. So, just remember, like, all of these instruments are very important to the function of the vessel as a whole and the safety of those on it. There's autopilot, very commonly. There's also UHF, VHF. If you guys don't know, there's marine radios. There's a whole standard there. And then compass stuff, which the compass on these boats, a lot of these boats are pretty cool, actually. I'll show you the packet stuff, but like they have not just this heading, but like a lot of times I'll tilt sensors and stuff like that too. So there's a lot of data there. So the old school protocol that was used for this stuff was NMEA 0183. And to answer your question, I don't actually, I think it's something marine. I don't remember what the NMEA actually stands for. I have to look it up. But like I know it's just a standard, protocol name. So anyway, NMEA 0183 was the older school one. It's serial ASCII based. I have an example up here. This is a GPS packet, essentially, not packet, but frame, whatever. Anyway, basically, NMEA 0183 had issues. It's been around for a super long time. It's slow. And one of the biggest issues with it is that it doesn't actually provide power over the bus. So it's like not that easy to implement. You have to make sure every device has power separately. Also, it's one way. So like if you want to implement NMEA 0183 both ways, you need like 2 cables going back and forth between those 2 devices. It's very direct. It's not really made for putting a lot of devices on a bus and having them communicate. It's really more of a point-to-point thing. So like I said, this is a legacy standard, but it's still out there. You'll see NMEA 0183 either used in old equipment, or sometimes you'll see it as like sometimes it's just a segmentation thing. So sometimes they'll use NMEA 0183 to like segment from the NMEA network. So they'll have like a GPS that's connected directly to an autopilot or sensor, that it isn't on the bus, even though they have the bus too. Uh, so NEMA 2000's the newer standard, and this one's the one we're going to talk about a little more in depth. So NEMA 2000 does allow power on the bus. It's got multiple talkers. You can have up to 50 nodes, and I think there might even be ability to have some more with some tweaks. Um, and it supports a lot of different instruments essentially. It's CAN bus based, so that's where I kind of peaked. I was like, well, can I do something with the CAN interface that I already have? Um, and it's 250K versus the 4.8K of the NEMA 0183. So a lot more data can flow across that bus as well. Uses PGNs. We'll talk about that a little bit later in the presentation, but PGNs are parameter group numbers. It's the messaging format that it uses. And then it's got additional, like, I'll point this out here. So like these are NEMA 2000, this is NEMA 2000 data, and essentially you have the sequence counter here, and then there's the frames. So like if you do standard NEMA 2000 is just, essentially like one string of data here, but you can do multiple frames by incrementing your frame counter. So you can do larger packets, and that's up to, I put it on here, 223 bytes versus the 8 bytes for a single frame. So, and there is something here, there is another standard. It's very rarely used. I haven't really seen it in the wild, but there are standards to do even more than that if it's needed. So let's talk about NEMA versus automotive CAN bus. This is where I was going down that rabbit hole trying to figure out, like, I have car interfaces, like what can I do? So really, as I was mentioning, it's already CAN bus, it's already CAN bus based. So the big difference between the two is two things. It's speed of the bus. An automotive CAN bus runs at 500K, whereas a NEMA 2000 bus runs at 250K. So if you have an interface that allows you to control speed when you're connecting to the interface, you should be able to communicate on that bus. So I'm like, okay, checkbox, one, I got, something, I maybe can make progress there. So NEMA 2000, as I was mentioning before, is more of a messaging format for that bus. It's a proprietary messaging format. So that's how the data is encoded in that as it's communicated across the bus. And so basically, like, I'm just trying to think what other point I wanted to make here. Yeah, so I'll just mention, like, CAN bus, whether it's automotive or whether it's on a vessel, or whether it's on an airplane or a train or anything else, these CAN bus technologies are older. They didn't really think about security when implementing them, so keep that in mind. A lot of times the answer to fix this stuff is just like, oh, well, as an entire industry, we're just all going to move to Ethernet, which I don't think is entirely realistic, especially in the maritime world where some of these vessels, have equipment that's literally been running for 30, 40 years, like at this point. Like, so, if it's a car, sure, the time for that to change is going to be a lot quicker. With vessels, I imagine it's going to be like, any change is going to be like 20 years, so this stuff is vulnerable in a lot of ways, and it's going to continue to be vulnerable for the foreseeable future. And I think the path forward is probably Ethernet everywhere, but that's a lot of cable to run in a vessel in really cramped spaces. So NEMA connectors. So the NEMA 2000 bus, they actually have really nice connectors. These are standardized, so I've actually heard these are used on like large vehicles, like trucks and stuff as well for their CAN bus, like city vehicle type vehicles, not just like a pickup. But this is an example down here of a NEMA 2000 backbone. So that's kind of like your get started device. It's got a bunch of different ports and you can plug in different pieces of equipment. Remember, it's a bus, so you're just bridging all of the devices together essentially on this bus. It needs to be terminated. So you have to make sure if you don't have something plugged in that you terminate those ends. And you can always add, these connectors are really nice to add stuff to. And they're super rugged. If you need stuff more rugged, they have like specialized Amphenol connectors and all kinds of other stuff that you can get. But these are pretty awesome connectors out the box. I was gonna say, like, as far as pinout goes, there's power, but for CAN, really there's two things. It's high and low. So you have CAN high, CAN low. So, and that's the same with automotive CAN as well. If you can hit CAN high and CAN low, then you can start doing fun stuff. So, interfaces. I'm going to start talking through different approaches. So, like, I like to think of this stuff as, just so you guys know, I like to think of like my targets and my tools. So, like, I don't know about y'all, but if I don't have like a project and like target a thing, like I will never actually figure out how to do the thing because like I learn skills by giving myself a task and trying to do that task. So I always think about like, what is my target? A lot of people ask me questions and they're like, oh, well, how do I do boat hacking? I'm like, well, what boat are you hacking? Like it really depends. Everything really depends on the specifics of your target. So, always keep that in mind, like if you don't know what you're attacking, like figure it out before you start attacking something, because you're not going to learn otherwise. ActiSense is a company that makes commercial gateways. These are NEMA 2000 gateways to connect to. I wanted one of these for a long time. On this project, I like just kind of peeked at them real quick, and I was like, oh, well, I wonder if these are still expensive. Okay, yes, they are. Let's see if I can do something with something that I have. They make really great gateways, but just like that's what I wanted to mention before, is the NEMA messaging format is proprietary. So it's been reverse engineered at this point, and there are really good resources that I'll have linked in the slide deck to show you all of the PGNs essentially. But it was a proprietary messaging format that was between those manufacturers and needed to be reverse engineered. It's just worth mentioning. This interface too, very proprietary technology, not something that's super, it kind of become a standard, but just because it is a device that is well used in the community. So anyway, wouldn't recommend getting one of these devices unless you just really want to support ActiSense for some reason. I mean, there might be someone who does. So this is the hard approach, and I actually don't recommend this approach, but you will learn a lot. So I'll have this stuff down in the conference center. I have a box with some of my gear that if you guys are curious to actually hands-on, show and tell, you can check it out. But this here is a white panda from Comma AI. I had extra CANBUS interfaces from them, so I figured I would give it a shot and see what I could do with that. If any automotive people in here, do you guys recognize this? Yeah? Yeah, but what is the connector? So it's an ODB2 from a car. So what I did was I cut off the outside and I laid the pins flat so I could solder to them. But just so you know, ODB2, here's CAN high and CAN low. So if you ever need to access CAN on your car, it's in there. So anyway, this project, I used that comma white panda. I used Python, and I was using the PandaCAN library. If you do go for a custom kind of route, what you're going to need is you're going to need some device to give you feedback. So whether it's a physical device like this is just a Garmin GPS that I had, a chart plotter, and I have a test one too that I'll let you guys play with in the conference center, look at, that I did some destructive testing on. I guess I could tell the story of that device for a second. So my spare device, it's really annoying because these are like cheaper chart plotters, so they're all in one integrated and they have a built-in GPS. I want to use this GPS, not their GPS. So at first, what I did was I broke off the internal GPS antenna, and it's like, oh well, if it doesn't get anything, it's not going to send me anything across the bus. And so it instead sent all Fs. And I was like, okay, well, that's cool. I could filter those. That's okay. But what if I disable the GPS chip? So I physically disabled the GPS chip, thinking that the device would boot and happily connect to the CAN bus and use other GPSs. But there's a check during the boot sequence that goes, okay, if this GPS chip doesn't check back, we're just not going to boot at all. So it's a brick device. But lessons learned in hardware hacking, is a spare device that I had. I'm like, well, whatever, So, but yeah, be aware, like if you're messing with electronics like that, sometimes there's software boot checks and stuff that you're up against. So, like maybe I can figure it out now. I'll reverse engineer it, patch the firmware. But anyway, so you need some kind of feedback to know that you're doing stuff on the bus. Like you can't really hack a website without being able to go to the website and see that you defaced it or whatever else. It's just you need some kind of feedback loop. So that could be something physical or something virtual. We'll go over virtual options very shortly. There are good open source options. If you take this route, the other thing I want to mention is that what you do varies a lot depending on what interface you're using. So whatever interface you have, there's going to be libraries for that interface that you could write custom code with. And you need to make sure first off that you can set the bus to 250, but then it's really just a question of how capable is that interface? Can you get raw data on and off the bus? It should be able to. Pretty much any interface, but like just be aware that specifics of that will vary a lot depending on what you're using. So this is the recommended approach out of this class. So I was like, oh, I don't want to buy one of those ActiSense gateways. I was like, is there anything out there that's open source at this point? Yes, there is. There's open source projects that essentially emulate, like they are ActiSense, like as far as any ActiSense friendly software is concerned. But on the back end, it's open source, and they actually have more features than ActiSense because you can connect to the little Wi-Fi hotspot, on your ESP32. I specifically recommend this device, the M5 stack, and it's really nice. It's super compact and just a nice overall device. But I can have that on a vessel and be a couple feet away and connect on my phone and look at the CAN messages from the web interface, and I can adjust stuff from the web interface. And it's like it's pretty slick. It's not all I'm trying to say is like you're spending $9 plus whatever tariff. Because this was a couple months ago. This is about $15 to get it off Alley. Questionable now, but these devices are still out there. They're also still on Amazon too. So if there's supply issues, try to look for, if you're looking for this specific device, really any ESP32 will work, but this specific one, check Amazon, stuff like that, just for stuff in stock. But like I was mentioning, this interface will work with any ActiSense friendly software, as well as really anything that you want to do. It also will transform NMEA 0183 to NMEA 2000 back and forth. So it can work as a gateway, whether or not you're trying to hack a vessel or you're trying to build your own GPS system for your sailboat or whatever. It's a really functional device. So if you're in maritime, just keep this kind of stuff in your tool belt, because I wish I knew about this like a couple years ago. So I'm going to talk about simulators real quick. So we have the target. And I'll talk about that software targets shortly. But if you have your target, what are you spoofing stuff, or how are you spoofing data on the NMEA bus? And how do you simulate real data so you can see it, so you understand what it looks like on a vessel before you actually go out to a vessel, or try it on your own boat? Or if you just need an example of what something looks like, you just want to understand it. Simulators are super important, whether you're trying to test the software that's on the navigation system, you can throw data at it and see what it says, or like I said, you're trying to develop some kind of exploit or just prep and understand what's going on the NMEA bus. So this is a free simulator. They do have a commercial version, I believe, but it's completely free. It works by sending messages on the NEM 2000 bus, and you can set all kinds of very specific parameters. So like uh, it's simulating all these different devices. You're able to actually go and change all of the characteristics of those individual devices that you're putting on the virtual devices, whatever you want to call them, that you're putting on the NEMA bus, as well as simulate pretty much all your instruments. It's got, engine, compass, GPS simulation. You can do like anchor simulation where, the boat is actually like drifting with GPS, a little bit to look like it's just sitting at anchor. This software has a lot of stuff built in. I was honestly really surprised. Um, so another simulator, this is the NEMA simulator tool. I honestly like the previous one more, but I wanted to mention this one. It also supports Signal K data streams, which is kind of cool. Signal K is another protocol that's used in a lot of this stuff as well, especially like if you're running virtualized GPS systems. Um, So targets. This one's really cool because like if you ever have a boat and like regardless of whether you're just trying to make a target kind of system to see that feedback loop, or maybe you have a vessel and you want to build your own GPS system. This is open captain CPN, whatever you want to call it. But essentially, Open Captain is an open source um, chart plotter suite. So, you can take this and then put it on an NEMA bus, and you could use the instruments that are on your boat, or it could be a completely at-home kind of lab environment that, you're just going to watch, what your simulated traffic is and, whatever your attack traffic is, and see what happens on the for our device. So this is another one here. This is a Coastal Explorer. This is a commercial one. I just wanted to list options for you guys just so you know that there's stuff out there. Like one of the things I try to do is I try to show like commercial, open source. So understand that. I like to think about like where stuff is from both because sometimes it's worth going commercial. In this case, Open Captain's really good. Say play with that. If you have a boat and you're trying to build out a chart plotter system for it, though. Coastal Explorer is pretty good for that. I know a lot of people who sail who prefer this one. So, so Comocom, this is going to come into play if you're using a Windows system and you want to play with, and this is beyond boat hacking, is just a good thing to have in your tool belt. It's for virtual COM ports. So you can essentially establish multiple virtual COM ports, connect them to multiple things. So you know how like COM ports tied up by one thing, you can link it to other COM ports and have multiple things connect to that COM port. You could also link completely virtual without a physical adapter and bus, from your simulator or attack software to your target. So, like I mentioned before, this is, Windows, but on Linux or, any Nix, you can use SOCAT to do something similar. So, so now we're just going to kind of talk about CAN bus vulnerabilities. Um, and this is kind of more of a general slide. So understand that the stuff here doesn't just apply to vessels in a lot of senses. First off, there's denial of service. Denial of service, obviously, you can spam the CAN bus. And if you spoof other devices on the CAN bus, you can basically cause them to be useless very quickly. So yeah, there's no rate control, and there's no real security on that bus, so it's very easy to kind of mess things up. Like if you get on that bus, you have a lot of access already. You're trusted to a degree. Um, anyway, so denial of service, pretty standard. There's also spoofing, so that's actually like assuming that the position of another device. We'll talk about that a little more in detail in a second. I have another slide that covers it. Oh, and for the denial of service, so the fixes for a lot of these are going to be similar. but there's ways to segment the CAN bus network. So there's talking about sometimes you have direct serial connections between devices, so it's not on the general bus if it's something super sensitive. There's also CAN bus firewall software out there that will essentially allow you to segment CAN bus networks. It's not software, it's like a hardware device and suite thing. It's really expensive commercial stuff that I haven't played with. So anyway, I would love to play with that stuff, or maybe develop my own. I've been thinking about messing with control between CAN bus networks. Anyway, so you want to isolate any critical sensors is the name of the game. If it's critical, if it can sink your boat, try to isolate it from the overall NMEA network, just because if someone does get onto that network, they have a lot of rights. So if we're spoofing, you essentially what you're looking at is a rogue device, fakes like being a legitimate device on the network. So you can actually bump that device off and kind of take its space on the bus, and then override real control data on the bus. And then fix for that. So let's talk about address claiming. There's a PGN I'll cover in another slide or two that basically covers how a device is adopted, onto that network. There's a specific PGN that happens, a parameter group number that it's a. I'll show you guys in the next slide. I won't spoil it. So yeah, you want to look at. I was talking about like commercial software. Some of those will actually alert on like address claims and any duplicate PGNs or weird stuff on your bus. There's also device fingerprinting stuff. So like I've seen some stuff that uses timing on the bus to determine whether or not there's a spoofing issue, like something happened and it's a possible rogue device. So for packet sniffing, as I was mentioning, if you're on that bus, you can see stuff. So, sniff away. A lot of times you can see sensitive data. Sometimes knowing just that data could be very valuable. So you have an implant on a ship and it's not broadcasting AIS, and you see the GPS data and you know where that boat is. There could be other sensitive data that's leaked that you shouldn't be privy to. There's a lot of stuff that could happen there. You want to mainly like for this remembering that physical access, if person has physical access to that bus, it's key. I mean, it's like similar to a server, right? If someone has physical access to a server, they own it. Especially true with NMEA buses. If they can get on that bus, they can talk to anything that's on it. So man in the middle attacks. So you could put an inline device that messes with the data that's sent across the bus. So rewriting, trusted, speed data, depth data, etc. Because it's a bus, data is passed along that bus, and if you're in between, yeah, it's not hard to man in the middle of it. So talk about PGNs for a second and give you a little bit of an example. Remember I was mentioning that the protocol's been reverse engineered for NMEA 2000. This is the QR for that. It'll have breakouts for the different PGNs like this. This one's for speed, so PGN 128259, but it'll actually show you how it's broken out. This is just an example for you guys. And if you're working with NMEA 2000 data, reference this as much as you can because it's a proprietary protocol, so there's like not a lot of good sources out there. This has pretty much everyone reverse engineered. And you'll see some example other PGNs down here. So I listed one for rudder position. So that's the rudder your boat, that steers your boat, so that could be, if you can modify rudder control, that might be something worthwhile. Vessel heading showing compass heading, and that's another thing that if you can mess with that or deny that to the systems that need that could be very dangerous. If your autopilot thinks you're going in one direction, then you're not. Speed, so that's pretty standard. So there's actually multiple speeds for boats because you have to imagine like speed through water or speed over ground, SOG, speed over ground, but it's speed through water. The water's moving. Remember that. So speed on the water is different than how fast you're actually moving from a GPS perspective. So that's why it's water referenced. It's a speed sensor in the water. Um, so that next one's a very important GPS one. So that's the rapid update for GPS positioning. That's just like constantly trying to tell the GPS essentially where that GPS receiver says it is. Then there's wind data for sailing vessels, or I guess a lot of vessels have wind data, but yeah, that's just another example. And each PGN is essentially like this. It's defining what that PGN, what kind of data it supports, what it's going to look like on the bus. And it is a standard. It's just not open source standard. So let's see. Yeah, so that's another important thing. So devices, the way that it works is all these PGNs are put out on the bus. Devices are going to filter and only work on PGNs that they understand. So like a GPS is going to say like it's just going to pass on everything else, so it's not going to worry about it if it's not a PGN that is related to what it actually is trying to do. Uh, so bus priority and spoofing. So this is where I just wanted to talk through spoofing a little bit. So like the big thing that the way that spoofing would work on a vessel is that there's this address claim that happens where you claim an address on the bus. And when that happens, there's a name value, which is essentially made up of the manufacturer, device function, industry group, unique ID, a couple other elements. And then if you have a lower name value than the other device, you're going to be prioritized. So you can just use a lower name value and then take over that position on the bus. So that's kind of how spoofing works here. There's uh, oh yeah, so address. I'm just listing it. So like addresses aren't fixed like IP device must have at runtime. So that's just, yeah, the bus is fluid. Anytime someone can make an ISO address claim, PGN send out ISO address claim on the bus and go through that negotiation. Um, oh, and sorry, two devices can't use the same address, obviously. So that would be a denial of service, whether or not you're sending good data. So you can just spoof a bunch of stuff, and denial of service is easier, obviously, than actually sending real data. It's fun to see your GPS all of a sudden, all the lines go flat, because you sent it something. That was my first like, oh, I had success, but I wasn't controlling those lines yet, So uh, future projects. So things I'm working on. I developed some code during that boat project to do like that simulation of GPS data on the NMEA bus. I want to expand it to standard interfaces because essentially right now it's what I build out on that Panda interface, and it's not really something made for other people to use. It is just stuff I threw together. But the idea of the project I think is solid, and I think there's a lot of use cases where a lot of these companies, I feel like GPS is right until it's not. So like are having to hire like a super fancy hacker to like come in and do GPS spoofing, and you have to find a lab or some way to isolate your radio, so if you don't go to prison. Uh, like it's just a huge lift, and I don't think the maritime industry as a whole is able to do that at scale. So what I want to do is I want to introduce a piece of software that can use some of these standard interfaces to do common GPS spoofing attacks, just simulated on the NMEA bus. So similar to that simulator software that I've shown you guys before, but instead of just simulating GPS position, we would simulate things like an attacker who's close by, and all of a sudden the GPS, goes from being a weak signal to a very strong signal. Does the receiver notice that? Or GPS is based on where all these satellites are in the sky. So, your GPS receiver knows what a good constellation looks like, or it should. It shouldn't trust a bad looking constellation. If the satellites aren't where they're supposed to be based on ephemeris data, it shouldn't be trusting them. So there's a lot of stuff that you can kind of like, as you level up from just like trusting all GPS data, there's attack scenarios that I want to kind of build out and give the maritime industry an easy way to just throw something on their NMEA bus and test that. I don't know entirely what that's going to look like yet because I'm still working through it. But I know I don't want it on a comma panda. I want to use one of these open source projects and build it out on there. So um, the other thing I'm working on, I have a domain now for vesselhackingplaybook.com. I also have hackingplaybook.com. There's nothing on them yet, don't worry about it. But like, I've been talking to a couple friends who also do various types of vessel hacking. It could be, from a physical engagement, like starting on a cruise ship and getting physical access and getting access to the NMEA bus and the shipboard networks and owning those. I have friends who do a lot of physical type stuff like that. But also anyone who's interested in vessel hacking, I would kind of like just make a place where I can get my resources and my notes together, but also pull in my friends who are amazing and way smarter than me in some senses. So I want their input and their feedback on that stuff, and I want to create something that's just a really good resource, not just for myself, but for the community, because it's like, why build out notes for myself and hoard that? So working on that. And I don't have an ETA for either of them. I am pretty busy this year, so they will come when they come. But the vessel hacking playbook one will probably come sooner. I'm thinking the next month or two, at least the start of it. And it's going to be sourced from a repo on Git. So if you guys want to contribute to it, you can just contribute on Git. It'll be very simple. And then, yeah, let's open up for questions. That's my puppy at Secure Ideas. They're lockpick things.